This is a video on mathematics for the students of class 9 and we are discussing the chapter Indices. Let us discuss the first sum today. We have root over of Lm to root of x to the power L by x to the power m. Then we have a root over of Mn. Within we have x to the power m by x to the power n. Here we have x to the power n by x to the power l root over of nl. So what we see is all the numbers are having root over of product of two variables. So what we can do is let us simplify the numbers within the bracket. So x to the power l by x to the power m can be written as 1 by lm. X to the power m by x to the power n can be written as 1 by mn. X to the power n by x to the power l can be written as 1 by nl. Now since the numbers with same base having different powers are there, so we can subtract x to the power l minus m. Similarly, x to the power m minus n, x to the power n minus l. Now since all the numbers, if we take them out, so it becomes L minus M by Lm, M minus N by Mn, N minus L divided by Nl. So now since the bases are same, so powers will be added. So on addition, we need to find out the LCM of all the three denominators, which we get as Lmn. So when I solve this, we get plus L minus M plus m minus n plus n minus l. So all the numbers with positive and negative values gets cancelled. So we are left with x to the power 0, which we know is equal to 1. Next question, we have question number 21, where we have x plus y plus z is divided by x to the power minus 1 into y to the power minus 1 plus y to the power minus 1 into z to the power minus 1 plus z to the power minus 1 x to the power minus 1, which is equal to x, y, z. Now we know that since the left hand side, we are solving first the left hand side, so we have x plus y plus z divided by 1 by xy plus 1 by yz plus 1 by zx. So all the negative powers I have converted it to powers. On taking the LCM, we get x, y, and z. So we have z plus x plus y. So on the converting the numerator into denominator, so we get x plus y plus z. Since division is changed to multiplication, so we have x, y, z by x plus y plus z. So they get cancelled. So we are left with x, y, z. Hence proved that left hand side is equal to right hand side. Next we have question number 22. Here we know that a to the power a is equal to c to the power z, b is equal to a to the power x, and c is equal to b to the power y, and we have to prove that x, y, z is equal to 1. Now if I just substitute the values in any of the equations, so I'm starting with the first one, that is a is equal to c to the power z. Now we know that the value of c is b to the power y. So instead of c, if I write b to the power y, so we have z outside the bracket. Now if I have to multiply this, so it will become yz, and we know that value of b is given to us as a to the power x. So it will be is equal to a to the power x, y, z. Now since bases are same, so powers are also going to be equal. So we can say that x, y, z is equal to 1. Now I have used to solve this or to prove this theorem by taking a is equal to c to the power z. You can also try by taking b is equal to a to the power x or c is equal to b to the power y. You'll get the same answer. You can try solving this on your own. Next, let us go to question number 24. Here we have if 2 to the power x is equal to 3 to the power y, which is equal to 6 to the power minus z. So we have to prove that 1 by x plus 1 by y plus 1 by z is equal to 0. So I'm assuming that 2 to the power x and 3 to the power y 6 to the power minus z all are equal to k. So I can write down 2 to the power x is equal to k to the power 1. Now since I'm assuming that 2 to the power x is equal to k, so I can also write down this as 2 is equal to k to the power 1 by x, whereas 3 will be equal to k to the power 1 by y, and 6 to the power minus z is also equal to k, which I have made the powers positive by writing this as 1 by 6 to the power z, which is equal to k. Now we can expand 6 as 2 to the power 3. So on this equation, let us solve this. So we have 1 is equal to k to the power 1 by z. I have taken this on the right hand side, 2 into 3, and then substituted their values. So since bases are same, so powers can be added. So we have k to the power 1 by x plus 1 by z. Now since we have here 1, in order to simplify our solution, we can also write down 1 as k to the power 0. So when bases are same, so powers are also equal. So we can write down this as 1 by x plus 1 by y plus 1 by z is equal to 0. Hence left hand side is equal to right hand side, hence proved. So this is all we have from the video today. Thank you. We'll continue with the chapter in the next class.